All right, we are back for Astronomy in the News. Now, we had a month off from doing Astronomy in the News last month because we had an extra speaker. So we had to be really, really selective of what stories from the last 2 months we can include. So this is the very, very high highlights of the last 2 months in astronomy.
So first up, or not.
Or not.
All right. So first up, this is an artist rendering, not an actual image, of a supernova, an exploding star, what I like to work on. We'll see a real picture of a supernova in just a few minutes. But a pair of studies came out at the beginning of the month saying that about 2.2 million years ago, a supernova went off. A star exploded right in our own backyard, a mere 300 light years away. And the two papers that claimed this did so based on the fact that a specific kind of iron has been detected in sediment layers in the ocean all around the world. So the supernova went off. It was brighter than the full moon for a couple of weeks. You could see it during the day about 2 million years ago. Dusted the Earth with this specific kind of iron all around the world, and then that's now in deeper layers in the ocean. And we know it's from a supernova because supernova make lots of different kinds of iron, but the specific kind, iron 60, decays relatively quickly. It's radioactive. And so the Earth was probably formed with some. It decayed away a long time ago. And the fact that we see it in the ocean beds right now means that it had to have been dusted on the Earth not that long ago, about 2 million years ago. So a nearby neighbor supernova didn't burn off the atmosphere and ocean, but would have freaked out any ancestors of ours hanging out 2 million years ago.
Next up, we have some sad news. This was an X-ray telescope launched into space by the Japanese. It was going to study, among other things, black holes. It was launched on February 17th. It immediately seemed like things weren't quite going right. What we now know, as of March 25th, is that the internal control sensors in this telescope thought that it was spinning. Now, it wasn't actually spinning, but the spacecraft thought, haha, I'm spinning, I better counteract that. And in counteracting it, it actually started to spin. So things went from bad to worse. 5 pieces broke off of the spacecraft, including the solar panels. On March 26th, ground controllers couldn't contact the spacecraft, and that's when they knew something had gone terribly wrong. Amateur astronomers were actually able to track the satellite, and the big changes in brightness they were seeing meant that it was indeed tumbling out of control. You can see that on the video here. There's something moving across the screen that gets brighter and fainter, brighter and fainter. That's the spacecraft as it's spinning around. So Hitomi has not been heard from since March 28th, and so it is sadly presumed dead, which is a huge blow for X-ray astronomy.
On Monday, May 9th, we're going to have a relatively rare celestial occurrence. Mercury is going to pass in front of the sun as seen from Earth. This is what's called a transit. Mercury does this every once in a while. Venus does it even less often. The last Mercury transit was in 2006, and the next one will be in 2019. So check this one out. Warning, do not look at the sun with your eyes through a telescope or binoculars unless you have special filter or special glasses. So you can have a solar filter on your telescope, you can get special eclipse or solar viewing glasses, you can project the image of the sun through a pinhole in a piece of paper onto the ground or the wall, or for all you welders and steampunk makers at home, number 14 welder's glass. That actually will be good enough. You can look through that and watch the transit of Mercury. Local time, it'll start at about, where's that in my notes? It'll start at 6 a.m. and end around 3 p.m. So that'll be a pretty neat thing, assuming it's not too cloudy.
So staying within our solar system, on March 16th at 7 p.m. Texas time, Jupiter got hit by something. We think it was either a comet or an asteroid, about 50 feet or so across, although that's pretty uncertain. At least 2 amateur astronomers spotted this. Gerrit Kernbauer in Mödling, Austria, with a 20-centimeter telescope. And then this video came from John McKeon in Swords Island with a 28-centimeter telescope. So at this time, Jupiter is just over 400 million miles away. You can see on this video here the bright flash that comes up. That's the thing hitting Jupiter. You can also see in this image here 3 of the moons, and they are from left to right, Europa, Ganymede, and Io.
Now, on to Saturn. In the end of March, astronomers announced that some of Saturn's 62 moons, as well as its ring system, are a mere 100 million years old. So they were formed in pretty recent history on geologic and astronomical timescales. So the big claim that you might have seen the headline was, the rings of Saturn came about after the extinction of a handful of dinosaurs. So they're hanging out on the ring system.
So this is a cool image that was released on March 31st. It's from the Atacama Large Millimeter Array, or ALMA. Hearing that name is making all the astronomers in the room twitch because the proposal deadline for that telescope is this week. This is a radio telescope located in the Andes Mountains in Chile. And this image here is showing the finest detail ever seen in a planet-forming disk around the nearby sun-like star TW Hydrae. At the center of this, you can see a gap, which is the same distance from the star as the Earth is from the sun, which might mean this is a disk of gas that's forming planets around the star. So this could mean that an infant version of our home planet, or possibly a more massive super-Earth, is beginning to form in this region. And if you're interested in this kind of thing, we're going to have a full talk on images like this and the formation of planets next month.
All right, as promised, I'm going to talk about the press release that I was part of. So here is a picture of a supernova here. We've got a galaxy, and this bright spot is a star that exploded in that galaxy. This supernova was discovered in 2012 by my old research group at UC Berkeley. But then my current research team here at UT, led by Professor Quantum, an AOT alum, studied this supernova. And this guy up here, Howie Marion, a researcher at UT, compiled data from Berkeley, UT, and about a dozen other institutions around the world, and this supernova looks very normal. It's the kind that we use for cosmology, the kind that you'd use to discover dark energy, et cetera, et cetera. But the weird thing we saw was extra blue light in the first few hours of the explosion. And this matched theoretical models. Here's a picture of a couple theoretical models of this dense dead star that's exploding next to the companion star that it stole material from and then exploded. And you see this kind of bow shock because the explosion is ramming into the partner star, and that heats up, gives off a little extra blue light for a few hours, and then disappears. No one's ever seen this in a normal type supernova, and our group was the first to see it. So that was pretty rad. I was glad to be part of that. Yay!
So next up, we have a press release from my field, but one which I was not involved with. At the beginning of March, it was announced that the Hubble Space Telescope had been used to calculate the distance to the furthest galaxy ever measured. So Steve was talking about redshift earlier. This one is supposedly at a redshift of 11. But as he hinted, we think this is maybe a little bit dodgy. It has a really imaginative name. As I always say, astronomers should not be allowed to name anything. This is called GNZ11 because it's in the Goods North field and it's at Z of 11. There you go. So if this really is that far away, this is this red blob you can see. We're seeing this when the universe was only 400 million years old, so about 13.3 billion years ago. Or when the universe was about 3% of its current age. As I said, we're not entirely convinced by this. I won't go into the technical detail unless you ask me afterwards. But the method that was used to calculate the distance has huge uncertainties on it. So Steve and I were actually at a conference a few weeks ago run by the guy who discovered this, Pascal Houche. And in the bar, I made a $1,000 bet with him that it won't turn out to be real. So I'm not paid that much, so I really hope this does not turn out to be real.
On April 8th, many people saw this. SpaceX successfully launched a Dragon capsule to the ISS. It got there safe and sound 2 days later. And then less than 9 minutes after launch, the rocket booster, seen here, flipped around and landed on the autonomous floating ship called the Of Course I Still Love You. Aww. Woo! They have tried a few times. This is the first time they've successfully landed the thing on the autonomous ship. So there was the view from one of the chase planes. And in a sec here, we will see the view from the actual booster, which is pretty impressive. Automatically landing by itself on this ship in the middle of the Atlantic Ocean. Here we go. From the booster itself, you'll see the legs flip out in just a second. There they go. And then the retro rocket kicks in right here. And 10-point landing. Well done, SpaceX. Congrats.
Yeah, they should really name those boats Boaty McBoatface and prove that they're cooler than the Brits. So finally, Breakthrough Starshot. This is an initiative led by Yuri Milner, a Russian philanthropist and internet entrepreneur, Stephen Hawking, Mark Zuckerberg of Facebook. This was announced on April 12th. The plan, it's a very vague plan, is to send a fleet of robot spacecraft, no bigger than iPhones, to Alpha Centauri. This is our nearest star, which is a mere 4.5 light years from us. So the estimates are that this is going to take about $10 billion and a decade just to develop the technology necessary to do it. The spacecraft would have these little thin sails that would be propelled by laser beams from Earth. These are the laser beams down here. Within 2 minutes of the lasers turning on, the probes would be more than 600,000 miles from the Earth. So this is as far as the lasers can maintain a tight beam. At this point, they'll be moving a fifth of the speed of light. It's still going to take about 20 years for them to get to Alpha Centauri, but that's a little bit quicker than the 20,000 years it would take our current fastest spacecraft, the Voyager spacecraft, to get there. So 10 years to develop technology, 20 years to get there, another 4.5 years to get the signal back. So maybe in about 35 years, we might be looking at our first data from Alpha Centauri.
All right. And that is Astronomy in the News. Thank you guys very much.